Welcome back. In this lesson, we will explore how to predict values using our standardized model. Imagine you got some new data. For simplicity, I'll create a data frame with two observations. One is a student who got 1,700 on the SAT and was assigned the number 2 randomly, while the other had 1,800 on the SAT and was assigned 1 randomly. It is crucial that our new data frame is arranged in the exact same way as our input data, x. After we confirm this, we can proceed to predicting the new values. We can simply call the predict method on the regression and then specify the new inputs as an argument. So, reg predict new data. The result that we get is quite confusing. 295.4 and 312.6. This is not even a valid GPA. This happened because our regression model was trained on standardized inputs. It expects values that are of the same magnitude as the ones used in the training process. A minute ago, we explained that the new data frame should be arranged in the same way as the input x. We can add that it also must be standardized in the same way, with the same mean and standard deviation, that is. But we already have that stored in the scalar object, right? Let's use the same methodology then. New data scaled equals scalar dot transform new data. The result is an ND array, which contains our standardized data. Now that looks exactly like the inputs we trained the model with. Using the well-known method, predict, we can find what the predictions are when we feed the new data scaled array. Here's the result. It is of the magnitude we anticipated. Our first student is predicted to have a GPA of 3.09, while the second, 3.26. Fantastic! I bet you must be wondering what would happen if we decided to remove the RAND 123 feature. Theory suggests that nothing should change, right? There's only one way to find out. As usual, you can try to reach that result on your own. Alternatively, please continue watching. Since there will be no new information, I'll go rather quickly through the code. First, we must create a new regression. I'll call it reg simple, as it is a simple linear regression. Next, we must declare the inputs. Let's create a new variable called xSimple, which will contain all observations from x scaled from last lecture, but only referring to the SAT column, or column 0. If you remember, SKLEARN would return an error if the inputs are not of matrix form, so let's make it a matrix with the reshape method. Next, we fit the regression with inputs xSimple matrix and outputs y. Once the regression is fitted, we can proceed to predicting the new data. Reg simple dot predict with argument only the first column of the scaled new data. It is crucial that we only feed the SAT score because this regression was trained only on it. Moreover, once again, it must be reshaped so the code executes properly. Here's the result. Let's compare it to what we got from our multiple linear regression. The predicted GPA is slightly different, but actually if we round up to 2 digits after the dot, we get the exact same results. 3.09 and 3.26. This finding shows us why the developers of SKLearn have decided that p-values are not needed. When we apply feature scaling, it often does not affect the final result if we keep or leave out insignificant features. Their weights will be so close to 0 that they will barely influence the predictions. Great! We learned a lot in this lecture. In our next lesson, we will explore yet another new concept. Thanks for watching.